Great. Again, welcome everyone. Let's get started. Welcome to this embedded UI webinar from ST Microelectronics and TouchGFX. My name is Søren Mikkelsen, and I'm an account manager at ST and TouchGFX, and I will be your host for today. Our subject for today is choosing the right embedded display and touch solution. And especially choosing the perfect display for your embedded UI project can be challenging. The display itself is one of the most expensive and important hardware components in your setup. And the display is the interaction point for the end user. So having the right size, fitting a specific environment, and also meeting the expectations of smartphone look and feel is challenging. We at TouchGFX have had a lot of questions about this topic. And this webinar today is to help you make the right choice. So we hope you'll find it beneficial for attending this webinar. Next slide, please. With me today, we have the Managing Director of EDT Europe, Michael Melvang, who will take you through the different topics. Hi, Michael. Before handing over the microphone to you, let's meet one of the people behind the scenes and ready to answer some of your questions. Say hello to Jørgen Myggen. I think he will come in from the side here. Great. And please ask a lot of questions. I can already see you are asking some. He is ready to answer it, and some of them we will be taking up here at the webinar. Yes, next slide. We are using GoToWebinar, and this is the setup, and you can use questions and chat, and we will also have some polls to get your inputs on different areas and some info. And I think we should try one out. I will find a poll here to see what level of display and touch solution knowledge you have. So let's launch this poll, and you can put in your vote, and let's see where you are. And while we are waiting, please note that, again, this webinar is recorded, so we will make this available afterwards. When attending, you will get an automatic email with the recording, and we will also share this on our website, both on the TouchGFX website and I think also on the EDT website. Yes, and I will close the poll now and share the result. I can see it's good, average, and poor level of knowledge, and I think this is really great. I hope you can learn as much as I can on this webinar. Yes, great. I will hide this poll again, and I will hand it over to you, Michael, and please take it away.
Thank you very much, Søren. First of all, thank you very much for being given this opportunity to tell a little bit about embedded displays and to present the company that I work for. And but first of all, I think it's important for you guys to know who is sitting behind the camera, or actually in front of the camera. My name is Michael. I have been with EDT since 2012. I have 20+ years experience in the industrial display field, and especially displays and touch solutions has been my focus for many years. So what do we aim here? What's in it for you spending this hour? We do hope to share some experience that we have been collecting over many years. And by doing that, we hope to give you a chance to get a shorter way to your marketplace. And by doing that, I mean designing your product with a good high level of reliability, and also being very confident about what we're doing is certainly a very beneficial aim that we are trying to achieve here. Especially also want to enable you to make a good choice when you select a display or a supplier for your embedded display. So that's the aim, to try and give you some ideas and some thoughts, and forgive me if I sometimes have my EDT hat on. I'll try to take it off as often as I can, obviously. So let's see what we can do here. On the agenda today, we are, I will give you a short presentation of the company so you know what we are about and why we are here. And I will also then dig deeper into the technical issues that has been on the agenda since you registered for this webinar. And then, of course, there will be also a question and answer session after the webinar, but you are, as Soren has pointed out, you are more than welcome to place your questions along as we go. And I can see from the poll here that we have a majority of people with a relatively low knowledge about display. So I'm sure there will be lots of interesting questions all through the seminar. So, yeah, about EDT. We're a Taiwan-based company. We were founded in 1994, and we are listed on the stock market in Taiwan, in Taipei. Be free to go there. And in total, we are about 1,200 employees worldwide. You can see on the pictures on the left side, there's our headquarters in Kaohsiung, that's in southern Taiwan, and we have our factory a few blocks away, main factory, and that factory we build displays, we build touch panels, and we do optical bonding, we build everything together. We do a lot of product development in Kaohsiung factory. And then when we have designed things, we are moving into assembly production of some of the smaller displays. We tend to move some of the production to our production site in Dongguan in China. So why are we here today, sitting here together with TouchGFX and the team? It's primarily because we have been searching a long time for a good solution in terms of value adding to our display and touch modules. And a few years ago, we started developing this new concept of ours called Smart Embedded. And this has now resulted in three basic standard evaluation kits. As you can see on the slide here, we have made a standard module with a 4.3-inch display. We have made another one with a 7-inch display, and we have one with a 10.1-inch display, all featuring the STM3 F7 series MCU from ST Microelectronics, and with the TouchGFX GUI framework to present the graphics. So it's a very agile and smooth system that we have put together here. We have a question.
Yes, I think it's a good point taking up one of the questions which is relevant here. It says, Michael, where can I buy these modules, and can I just buy one?
Well, it's an evaluation kit, so of course you can buy one, and the best place to get it is to contact some of our partners or distributors. We do have a worldwide coverage, so we do have facilities in the US. We have two in US. One is in Boston, that's the main, and we have in Irvine, California, so east and west coast are covered. And there's a lot of reps in the territory who will be supporting you locally if you're on that side. And here in Europe, you are welcome to contact our partners, our distributors, or contact ourselves in Denmark. You will later on get an email address that you can contact. And you can, of course, also, if you're from Asia, I don't suspect there will be that many from Asia attending this seminar right now. But of course, there's also possible to buy it out there. Okay, right. So let's go on with it. Let's dig deeper into the embedded display. So many people consider a display to be just an off-the-shelf item, something you can go out and grab in any corner. But it's actually a very, very complex system, especially if we have a touch display as we are showing on the screen here. It consists of a lot of different materials and components that has to be combined in the right way and has to be sourced from the right sources to form a good embedded display. So there are some key questions that we feel is necessary to ask yourself, and actually more important, to communicate and have a dialogue with your supplier directly, and make sure to get involved very early in the process, because the closer contact you have, the better dialogue you have with your supplier, the better the chances that you will get a good solution in the end. So first of all, let your supplier know who is, what is the application, who is using your device, what kind of functionality are you after, and especially which environment do you want your device to operate in. That's very, very critical questions. And second question is concerns actually a commercial angle. How long are you planning to have your product in the market? How many times are you willing to invest in redevelopment in terms of when a component or a material reaches end of life scenario, etc. So that's very, very unique. Some questions that you have to be aware of. And then, of course, we can dig into the technical details and the technical requirements that you will be facing. But just to give you some idea, if you're looking at a consumer display, I mean, everybody carries around very, very advanced and modern display in their pockets. Perhaps the most advanced that you can get in the market. So naturally, the expectations will be very high when you go into a display project from the start. But it's not always very practical to have that kind of approach. So you need to discuss with your supplier and be aware. So let's look into the technical stuff. What's if we take such a display apart, you will see it consists of some module solutions, basically. In principle, you will have the driver board to interface it. It can contain an LED driver or maybe a converter converting the signal from LVDS to parallel RGB or whatever. I'll come into those interfaces a little bit later for those of you who are not so familiar with them. Secondly, it will contain a display, obviously, to show the information. That's the kind of the face of your product. Remember that the display and the touch is the face of your product. Then we will have some kind of bonding to attach the capacitive touch sensor or a touch sensor. It doesn't necessarily need to be a capacitive one, but obviously, if you are considering to combine it with a cover lens to protect it, that's the second thing. Then obviously you will need some kind of capacitive technology, and then of course not to forget your framework, your user interface software. But that's a different seminar. We will dig more into our smart embedded solutions later on in November probably. So digging into the displays, yeah, what kind of questions do we ask ourselves there? I'd say display technology, you will be faced very, very often with what we call an active LCD technology. It's also the technical term is TFT is very often used. But most of you, if you are not so familiar with that, will know from your supermarkets that you can buy LCD TVs. And in principle, a TFT panel is made with liquid crystals, hence the liquid LCD, and it is transistor driven, so it's an active display technology. And there are generally, I mean, obviously there are other types available, but the most common ones are the TN based, which is a very industrial type, and then there is the IPS MVA type that origins from the consumer market originally, and now gets more and more integrated and into the industry field as well. So, but then of course there is the general requirement for those technologies come from a desire to have very wide viewing angles of the display. And actually there are some tips, small tricks that we can put, like adding an SVV film on the TN display to achieve a better viewing angle. We will come into that a little bit later. So since the majority of projects that is seen in the market generally today are based on TFT, so this presentation will primarily use that term TFT and be focused on concentrating on that. However, there are still some other technologies like the well, it's not maybe the right term to call it a legacy product, but you will recognize the monochrome LCD display from many applications, and that's very, very good display if you're looking for long-term availability, and it's generally available. It's easy to drive if you have a small microprocessor system, so we still see some projects arising from this technology. And then, of course, we cannot forget and overlook the e-paper technology, which is good for signage, warehouse price tags, etc., where you don't need to update the information on the screen very often because it requires some high power to update the screen, and then you can take off the power and then the image will stick on until you update it again. That's a benefit. On the other hand, you can't read it if there's no ambient light to reflect it. So, and of course, like I said, the advanced modern smartphones will be using maybe an OLED display, very nice technology that we do expect to see also rippling into the industrial market within the next few years. However, availability at the moment is still on a consumer level, so this is not something that we can consider for an industrial product at the moment. Right. So the next thing to discuss when looking at a display is usually people will ask about the brightness. And TFT display need a backlight to show an image. Most TFTs are what we call transmissive. There are some TFTs available with transflective technology where you don't need to activate the backlight to be able to read it, but the number of suppliers is fairly limited. So the most commonly displays are still the with an active or a transmissive requiring a backlight. So we have put together here a small table showing you the power consumption, because the power consumption in a display is widely defined by the backlight. It is by far the most power consuming part of the TFT display. So keep that in mind for the parts that will come later when we start talking about sunlight readability. And we do have another question, Søren.
Yes, we have a question about how much backlight should I have for an outdoor application?
Well, that's actually a very good question. It depends on the mechanical structure. It depends on the like, for example, if you have a touchscreen, there are many other things to consider than just brightness when we talk an outdoor application or sunlight readability issue. I say as a rule of thumb, some 600 candela would cover your demand as a surface brightness. But again, if we don't have optical bonding, I'll come back to that point later on, you might require a display with a much brighter backlight. So later on in the seminar, we'll show you a little bit more what this is about. But as a general rule, we should cover it. And for those of you who are not familiar with the term candela per square meter as being the measure units, some might know the other unit called nits, and they are same. But if you go to the supermarket and you buy a bulb, a LED bulb, you will often see the term called luminen, and that's another way of measuring brightness. But in the display world, display industry, we use the term candela per square meter or nits. And there is another thing to notice here. We will come back to that, but it's quite important and interesting now that you mentioned it, Søren, because sunlight availability, you have high brightness, but that's also where you actually want to fight back the brightness of the sun. So you need the higher brightness, and that reduces the lifetime of your LEDs because you will also have heat dissipating. So that's an issue here. This example here shows you a comparison between three typical 7-inch displays with different brightness levels, and you will see we have different lifetime of the LED backlight as per definition. And for those of you who don't know it, the lifetime is defined as the time until the display reaches half brightness at 25 degrees, measured at 25 degrees. So, and that is where your eye really starts seeing a significant change of brightness typically. All right. The third issue concerning a display will be the viewing direction or viewing position. And you have to be careful not to mix that up with viewing angle. If you look in the data sheet of a display, you will find a definition called viewing angle. And there is a general misunderstanding there that if a display is defined as a 6 o'clock viewing angle display, then the best viewing position will be from a 6 o'clock point. That's actually the opposite way around. I will explain that a little bit later, but just to keep that in mind, it's due to the way we measure the viewing angles. It's measured by a contrast measurement device, and the eye just perceives it differently. And what happens is actually that from a 6 o'clock angle, you will, with a TN display, see what is called grayscale inversion. So if you look at the picture here on the left, this is the same display seen from different angles. It's a TN display. It's a phenomenon that we see typically on TN TFT displays, not on IPS or MVA displays. So this is just for TNs. And you will notice a significant color inversion from the below angle, which is not so significant if you look at from above angle. And like I said, we do have some tricks that we can, like adding an SVV film, which can help to increase the viewing angle a little bit on the TN display. And in many cases, that's enough. That's just enough to get you going with a good solution, which is feasible, it's long-term available, and it's easy to implement and not so expensive. Right, then, oops. Let's look into the display resolution. Now, if you're designing an embedded system, you often have chosen a CPU or have preferred a CPU that you want to use, and you will design some software, but you also want to limit the memory size because your software needs to do this and that, and a lot of other things keep running than just showing graphic images on a display. So keep in mind, the higher the resolution you choose on the display, the more memory you will need, and the more CPU power will you also need for computing and generating the graphics. So that's one thing to keep in mind. And secondly, choosing the right resolution has become very difficult over the last few years because of the consumer electronics. As I said, every brand wants to have its own unique standout and tend to make their own display with their own resolution. So it's really hard to define a standard, but we can define like 3.5 inch with a quarter VGA resolution. I don't know if you are able to read the chart here. You can Google that. A quarter VGA means actually 320 times 240 pixels if it is in a landscape mode, and if it is a portrait display, then it will be defined as a 240 times 320. That's just one example. 4.3 inch is very common. 7 inch, typically with two different resolutions is available. Same with 10.1 inch, but everything in between is yeah, what is available from this panel supplier and what is available from this panel supplier. Everyone tend to have their own cherries, but be careful. Where do your display supplier source the panels, the key component here? Are they able to secure long-term availability? And how do they secure it? Very important questions to ask. And as I said, consider your needs. This is just 3 simple examples what kind of buffer size that you will actually need if you are running displays with different resolutions and different color depth. Keep in mind that color depth is really where you also will be facing some challenges, especially if you go up into 24-bit. It's quite a lot of data that you need to throw to the display. Unless, yeah, I keep doing that. That's fine. All right. The interface, yeah. What's the best interface for a display? Well, in many cases, it depends on the CPU that you want to use. Modern CPUs actually come with some standard interfaces. Today, if you are using a very modern CPU, you might find it's equipped with a MIPI interface. But if you're using more a little bit older generations of display or MCUs, you will find the display interface parallel RGB is the very, very common interface. And let's dig into that. We do have a question here, so Søren?
I think before we dig into the different interfaces, I think we should do a poll saying which display interface type is preferred for your next UI project. It would be interesting to see, what is the preferred one. I'll launch the poll now, and just please quickly type in your question. Yes, and I think we expect RGB to be the most common used, but let's see what we'll get here. I think we will close the poll now, and I'll share the vote. RGB and SPI interface is the most common used. Is that what you also expected, Michael, or what do you say?
Well, actually, yes. That's more or less what I would expect. I actually also find it interesting that so many are using MIPI already. That's a sign that modern displays are commonly used, because a MIPI interface is mostly used in very modern and found in very modern displays like mobile phone displays, tablet displays, where you have a very, very high resolution. The alternative to MIPI, if you're looking at a differential signal, there would be the LVDS interface, and the LVDS is commonly known or used in large size panels like 15.6, 15-inch, 12, 10-inch, and even down to 7-inch if you have a resolution of 1024 × 600. But below that resolution, it doesn't really make much sense unless you are striving at running very, very long cable lengths. And that is usually due to noise issues. But obviously, with a higher resolution, you will be running a much higher pixel clock. So obviously, it comes down to noise and how much can you protect your system and do noise filtering. Yeah, we can dig into it. The SPI is an interface that is used especially for the smaller displays, typically because you have a limited bandwidth there in terms of speed. And you can actually see here the calculation. I'm not an expert in the interfaces, let me just point that out. So, but it's considered if you want to show live video on a display with let's just say a VGA resolution or so, you might want to consider using either an RGB definitely for live video. But if it is more like simple graphics, but you want to change a little bit here and there, the MCU interface is actually also a very good option. And most of these displays actually come with especially the smaller displays below 3.5 inch actually per default contains a display controller on the glass, chip on glass controller, which actually features both MCU, SPI, or parallel RGB. It's just a matter of how we wire it up on the FPC. The MCU is a very nice feature. It actually has a small graphic controller built into it, and it has some memory, so you can upload the pictures to the memory and you can fire them off when you are ready to update the display, so you don't have to constantly bit bang the data bus. Or you can just simply tell the display or the controller to update a small portion of the display. You don't need to update the entire frames. So that's a very nice feature actually. The RGB is very basic. You basically have a frame clock. So there are two ways of running an RGB signal. One is the sync mode and the other one is the DE mode. And from our engineers, I have learned that it is very wise to choose the DE mode, because if you're running sync mode, you will have to have your clock and signals synchronized and running in phase, and just small disturbances, if they're not completely on time or on spot, you will see noise on your display. You will see distorted images, shadows, etc. So the DE mode is definitely a much more safe interface solution for the parallel RGB. And most of the display panels are still with a parallel RGB somewhere in the system, converted into either MCU or LVDS or MIPI by a controller in the end. And finally, yeah, the low voltage is the differential signal bus. You have two lines, two per bit, and actually when they will run in opposite phase. So you can imagine if you have noise radiating into your cable, one will be showing this and the other one will be showing this, and since they are in same sync, they will equalize each other out. So it's not so noise sensitive, actually will eliminate the noise by itself. Right, yeah, no more saying about that. Good. Remember, pop any questions as we go along. And then I'll switch over to the next topic here, which will be the sensor, because you want to interact with your display somehow. And the touch sensor is a natural choice of doing that. It's very intuitive designing a system. If you have probably seen the advanced graphic systems that you can be done with a TouchGFX framework, and it's very natural to put your finger on there and touch it directly. In general, there are two touch technologies commonly used. I would say, though, that most of the newer projects are done with capacitive touch technology. The number of resistive touch manufacturers has dropped over the years. It's getting a little bit harder to find a majority of manufacturers. Hence, the prices are not decreasing as fast any longer as they used to. It is a mechanical technology. You have a PET layer with ITO on the backside, and you have a glass backer typically with ITO. And ITO is a transparent material that when it's kind of acts as a conductor, so it's electrical conducting material. When you press the two layers together, they obviously form a contact, and that can then be detected in either by a simple resistive touch controller, or as we write here, just a simple analog digital converter, where it can actually act as a very simple touch controlling sensor. There are a few 4, 5, 6, 8, 7 wire technologies. Most common are 4 wire. I've seen a few 5 wires over my career, and even some 7 and 8 wires. Depends on which manufacturer you buy them from. However, as I said, today we do run into more and more into capacitive, and the reason for that is actually, if you look at the con side of the resistive technology, you cannot compare resistive technology with capacitive technology in terms of optical performance or look and feel. It's simply not on par. It will require the activation force, so if you want to do the same thing as you do on your tablet or in your smartphone, meaning sliding your finger and doing rotating and simulating, that's very difficult to do with a resistive touch. There are a few manufacturers who actually have made some very, very clever resistive touches that don't require a lot of activation force. But you still have the downside of a PET layer in front of the user, and PET, the polyester material, gets scratches on the surface with time. So we tend to see a lot of customers asking more and more for a glass type of touch and surface. So, and obviously you cannot make a Vandal Proof touchscreen with a resistive touch panels. I don't know how many of you have seen vending machines or ticket vending machines out there in the market, typically 15 or 17 or 19-inch screens, and people have cut them through with either a knife or scratched them with a key. Some are vandals, some are just careless, pointing with sharp objects, and the resistive touch is definitely not a friend with sharp objects. And furthermore, since you will have an air gap between the two layers always, the sunlight readability is really not easy to achieve with a resistive touch. So what is this capacitive touch technology about? And I do seem to have a small issue with my laptop here. Sorry for that. Can we have some questions?
Yes, of course we can. We actually have one question about capacitive touch. Can I use gloves when I'm operating a capacitive touch screen, and do I need a special glove to operate one?
You can use gloves on a capacitive touchscreen. I have seen the gloves that you can buy, which is handy when you want to use a glove and you're on your smartphone, because those technologies are not really suited for glove usage. But there is technology available in the markets where you can use gloves, even thick gloves or like medical gloves that are thinner. So that is definitely feasible. We are at that stage now. It used to be a bit of a problem, but yeah, today we have solved that. I'm sorry, I need to reboot my presentation.
Yeah, it's fine. Okay. And while you're doing that, Michael, I think we should launch another poll and get your input on what you find most important when sourcing a display. Just do that right away. I don't hear this. Only. Sorry, I think something happened to my microphone. Please type in what you think is most important when sourcing a display, and yeah, let's see what the results will be in a few seconds. Michael is restarting his PowerPoint presentation. Just wait a few seconds. Also about questions, please keep them coming. We see a lot of questions, but I think my colleague Jørgen can handle a few more. He's not sweating yet, but let's see if we can get close to that. I will close the poll and share one. Yes. Yes, and we have price as the number one, of course, and quality is also one important factor. Great. I think we are live again from Michael. Yes, I'll hand it over to you again, Michael.
Thank you very much. Yeah, sorry, I forgot to switch off on my phone or on my mic. So I think we are back now. The capacitive touch technology is the most widely used technology today in modern electronics. There are generally single finger touch available, and there are multi-touch multi-finger technologies out there. It's something you need to consider is what do you need to have? Do you want swipe or sliding features, or do you want zoom or rotating? I mean, if you're talking zoom and rotating, you will typically be looking for a dual finger or multi-finger system. If it is swiping or sliding, then it can be solved with a single finger touch sensor. And yeah, what kind of glove? We touched down on that. It can also work in a humid or moist environment. Early days, or we were not able to solve that problem, but today we are actually able of delivering touch panels which can work with, let's say, a limited amount of water on it. What you would also have to consider is the environment, as I pointed out to the beginning. If you are doing a public application device, you will need to consider how to protect your device, and that comes down to kind of you have to add a cover lens in general. And then it's a question, can your touch sensor actually work with a cover lens, or can it not work with a cover lens, etc. And definitely you will need to consider some kind of improvements for outdoor readability, or even Vandal proofing. So let's look a little bit about the two technologies most commonly used. For single touch, the self-capacitance technology was the most often used, and it's actually very good. You can imagine you have a sensor glass with some electric field hovering over it, and when you approach the field with your finger, then something happens. You change the electrical field. The self-capacitance actually pulls from that, as you can see on the illustration there. It actually pulls away some of the signal into the ground, and that makes it able to detect a touch even there is water on the sensor. On the other side, you have the mutual capacitance technology, and that's basically you have two sensors. You have a drive electrode and you have a sensing electrode, or also sometimes also referred to as an X and Y. And between those layers, there is a capacitive field, and when your finger approaches, you will change that capacitive field, and that'll be detected in the system. And hence, since it is a multi-touch system, you will actually be able to touch it with 5, 6, up to 10 fingers, depending on the sensor and the controller. That technology is, however, a little bit of a challenge if you have water on, and you can imagine why, because your finger acts as a bridge, water will act as a bridge. But with a limited amount of water on it, it can still detect it. But once you start sliding your finger around, then the controller gets confused and is not really sure where is the real touch that I want to detect. But today, actually, we have some very nice new controllers that work with both technologies integrated, and it can actually switch from one mode to the other mode, and it can detect if there is water on the glass. Then it can switch to self-capacitance and only enable single technology. And if the water is wiped off or running off, then it can switch back to the mutual capacitance technology, meaning you can start using 2 fingers again or more. But if you have a very thick cover glass on top of it, then obviously the sensitivity will be reduced. So there is always a compromise to be reached there. Some details. Be aware, the capacitive touch sensor, there's a lot of patents out there in the market. EDT, we have 148 patents already granted. In 2017, we applied for 10 more. So it's quite important to have your patent on here. Some years ago, yeah, one of the big A's in the US had their patent, and it was an issue. So just be careful where you get your sensor from and what kind of security they give you. Enough of the capacitive touch technology. As I said, you need to protect your skin. or the face of your product, and the Coverlens is a good way of doing it. The general protection is besides the general purpose is besides the protection also branding. The display is your face, it's your company face to the public. Keep that in mind. And by doing a clever logo design or a nice graphic design on your cover glass, maybe shape it kindly different to stand out of the crowd, you can actually achieve a very nice looking product. And even though you use a very standard display, but with the right GUI, with the right user interface, and with the right cover glass printing and shape, you can have exactly your own identity built just from this very, I wouldn't call it a simple system, but it's because it's fairly advanced, but that's what it is. And you will need to consider the material, the thickness of the material, obviously the protection level that you're looking for is quite important in terms of impact strengths typically. And then of course we can talk about the surface treatments. Like I said, if you can have water running off more easily, then you can achieve a better sensitivity and a better touch function. Hence some kind of anti-fingerprint treatment may be the best choice for that. Finally, of course, not to forget, the bonding and integration of this display touch system is really vital for your protection level. So let's dig a little bit into that. What do we mean? Yeah, we have a question.
Yes, just one question before we continue. We have a question from the audience asking, do you think, Michael, water and humidity PCAP problems are the mostly controller's problem or the sensor's problem?
It is mostly the controller's problem, but of course you will need to have the a clever sensor design. If you don't have the right pattern, which is tuned in for the controller, then you might have difficulties reaching the level of sensitivity that you are after. I think that should answer the question. It is definitely a question of the controller, but also, of course, who is delivering the system to you? Do you have a good access to the to get the right tuning of your software? Because that is really essential to any capacitive system. You need to have a good tuning facility or some guys who can do a good job for you there. I mentioned about vandalism and vandalism proof. It's quite obvious that the thicker the glass, the more safe you would feel. Actually, if you put 2 3mm glass together and you laminate them, you will have a very strong impact strength compared to a 6mm glass. So a laminated structure is actually very good in terms of absorbing the shock. Then obviously there is different kinds of glass available. Normal window glass, we typically call that a soda lime glass, can be chemically strengthened, hence the term CS glass for chemically strengthened glass. And then you will maybe be faced also or meeting the term tempered glass in the market. And it's come down to how do the splinters break up when they break. Tempered glass will break into tiny splinters, while a CS glass or a soda lime glass or even a Gorilla Glass will break into bigger splinters. So that is to be considered when designing your system. The Gorilla Glass is mentioned here. It's just a brand, but not just any brand. It's really a brand which is quite important, has been used for many smartphone applications over the time. But if you're looking for a 6mm Gorilla Glass, you would have to come up with a lot of money. And obviously there are other brands out there available that you can get at a better price. So it comes down to the project. What are your basic requirements? What do you need to have, and what then presents a reasonable alternative in terms of price performance relation. Obviously, it's also possible to add a plastic cover lens, but you will have to consider that a PMMA or plastic cover lens will need a hard coat surfacing to achieve a good scratch resistance. Typically, it's very easy to scratch a plastic surface, and it also bends and twists a little bit more than glass. Glass is quite flat if you look at it, and therefore we have a lot of restraints concerning plastic material as a cover lens material. Furthermore, the material constant epsilon, that's the electrical conductance through the material, is double as high in a plastic cover glass than in glass. So you can only have the half thickness of a cover glass in comparison to of a PMMA in comparison to glass material. So I've been mentioning this bonding structure quite a many times. If we have a cover lens, we have a sensor, and we have it then bonded together optically, and then there's a display. If we fill that material, that air gap out with optical bonding, you can see it's a very solid structure in comparison to the structure with air gap, which is a very typical structure used in most industrial applications. But nowadays, a lot of customers will want this optical bonding instead. And that comes down to the outdoor and sunlight availability, which we have touched on a few times. It's quite important. So when you are in an outdoor, you have sunlight, you have UV, be careful of that. Make sure to protect it. Most displays, TFT displays, contain a UV filtering polarizer, so that's fine. However, the paint on your cover glass may not resist UV light very well. And so you will want to use like a ceramic printed glass, for example, to have a strong solution out there. Then we have heat, and we have a lot of reflections. And that is the next topic here. You can obviously boost the backlight intensity 500 times or whatever, or 5 times. But by doing that, you will also burn 5 times more watt or effect out of your system. So you will have a lot of more heat to deal with internally. And that's quite a tricky thing, because you will be reducing the lifetime of your display significantly by doing that. Furthermore, the reflections is really critical here. So the way to overcome that is most oftenly, you can take a transflective display, a transflective TFT display. They are out there, but the number of panel suppliers is fairly limited. Hence, the prices are also quite in the high end. So the most common way is to do the optical bonding. It improves the contrast and the brightness, and even the viewing angle experience of your device will be improved. It also fills out the air gap where condensation often occurs. So by optical bonding, you will have no condensation issue, at least not between the display and the CTP touch sensor. Inside the unit, that's a different choice. That's a different webinar. And then, of course, you will not have dust particles or insects that can enter the visible area of the display, simply because there is no air gap they can come in. So the mechanical impact strengths, we've been showed that on the previous slides. But these reflections here, what is it? Any air to glass transition or glass to air transition will introduce 4% reflection, and that reduces your contrast by 4%. And contrast is the essence, that's the key. You want to have a highest possible contrast in a sunlight readable display. So on this example, you can see here we have 12% reflection coming from each time the light passes through a transition, in comparison to the optical bonded one. And here we have also taken the liberty of adding some kind of anti-reflection coating on the surface, which can help to reduce the top reflection to some 0.5% or so. So here you are looking at maybe a system with yeah, 0.7, 0.8%, or even best case here, 0.6% reflection, which is really, really good. So how does it look? This picture here shows it maybe a little bit schematic, but it clearly explains that the right side of the display is having an optical bonding, and the left side is without optical bonding. And it'll actually look like that if you take it outside in a display outside in the sunlight. I don't think I need to dig more into the ways of optical bonding, but there are commonly two types of optical bonding way. One is the optical clear adhesive, and the other one is the optical clear resin. It's two bonding methods. The resin is a glue that you apply, and you have to be careful that it does only go where you want it to go. It should not enter the display, where the OCA is a material that is mechanically put on the glass in there, and you can remove the air bubbles that will automatically appear by some kind of autoclave process where you pull them out. But in any case, make sure that your supplier do a proper job in the curing process, because if that material is not cured properly, you might encounter some issues over time with peeling or air bubbles re-entering where they're not supposed to be. And that is definitely not wanted. One way I mentioned about adding surface treatment, like an anti-reflection treatment to remove some of the reflection on the surface. There are various ways of surface treatments available. Commonly used is the anti-reflection, yeah, my glasses have anti-reflection, otherwise you would probably see a lot of shiny lamps in there. Just to show the practical example, what is that? If we add anti-reflection, we also want to add what is called an anti-fingerprint coating, and the reason for that is that the anti-reflection treatment is fairly soft in the surface. It is not so robust, so by adding the anti-fingerprint, we can actually increase the scratch resistance of the coating. The anti-fingerprint is a very nice and very hard coating. It's actually also the feature that enables your fingerprints to be easily wiped off the glass of your sensor. We cannot avoid fingerprints to come on the glass. They will come there, but they're easy to wipe off. And as I said, it helps to repel the water. So if you have anti-fingerprint, the water will easily run out. There's an anti-glare one. There's a kind of slide of milky white on the surface. And it's also commonly requested because if you have anti-glare, it kind of stands out in comparison to common consumer electronics like tablets or smartphones that typically has a more shiny and glare surface. So that's one way. We can do it with an etched anti-glare, which is very doable, or we can do it with spray coating, which is less doable, but also a more low-cost solution, obviously. And then, of course, we can add some antibacterial treatment, but I think surface treatments could be a subject for another webinar, perhaps in another time. Right, so coming to a conclusion here. Yeah, we meant to share some experience and to hopefully give you some ideas or to some key knowledge that enables you to get a faster approach reaching your market. And a little bit of reliability and confidence I hope to have brought over to you guys, and certainly enabling you to make a good choice. And as you see, our logo says EDT, it's the clear choice, so why not? I mean, that's very obviously. So keep in mind, we do have our smart embedded solutions. That's why we are here. We will be hosting another webinar together with TouchGFX. We plan for it in November. The date will come out later. Keep in mind, you can buy these smart embedded evaluation kits, which contains of a touch displays system with the STM platform on the back and TouchGFX. software already included, so you can download the GUI builder and start playing with it right away. So where do we get support? And we have a website where you can find your local contact points on there. And just to show you here, I think this is where I want to hand over the microphone again to Søren and say thank you very much for joining in and listening in. It's been a pleasure.
Thank you, Michael. Yes, as he mentioned, we will soon have a webinar addressing the smart embedded solution from EDT, and we will address also the TouchGFX part of this. If you go to touchgfx.com and download our TouchGFX version, you can actually find their display modules in the designer, alongside with different STM32 kits, evaluation and discovery kits, and yeah, it's plug and play actually. So this is really great. Please download it for free and try it out if you want. Next slide, please. Upcoming webinars, as I mentioned, we have the smart embedded, but next week we have another subject which is not hardware related, but in terms of graphics. Our partner Mjolnir Informatics is our partner at this webinar, and we will address user responsiveness and animations called Making Your Application Come Alive. This means that we will make sure, or we will show you how to have a UI which respond accordingly to the user's expectations and so on. I hope to see a lot of you there. Also, I would like to address some things happening in the US. We have different hands-on seminars on advanced graphics on STM32 and TouchGFX. More info will come, and if you would like, I can share it with you perhaps next week, where these hands-on seminars will be, and also where you can sign up. Also, we have a webinar. If you visit ST and go to the webinar page, you will find a webinar called Enhancing User Experience with TouchGFX. This is from our US colleagues, and if you do not know TouchGFX, this is a great way to get a really good introduction. And if you have any ideas or any topics you want us to address in a webinar, please let us know, and we will take them into consideration. Next slide, please. Yes, and please write us if you have any questions, both related to STM32, TouchGFX, embedded UIs, displays, and so on. We are happy to help. We will also do a survey after this webinar, and I hope you will help us and answer this. And lastly, I would like to say that it's been great seeing all of this interest for this webinar. And I have learned a lot today, and I think you also, or I hope you also have gained valuable knowledge for your next UI project. We will continue providing you with these webinars relating to embedded UIs. And if you have any suggestions again to other topics we should cover, please share it with us. I would like to say yes, thank you, Michael, for sharing all your knowledge with us today, and yeah, and that's it for us for tonight in Denmark. And yes, and thank you again for attending, and have a good night or good morning. Bye bye.